Today we're looking at notes 11.5, add and subtract rationals with uncommon factored polynomial denominators. So this is definitely different from before. Now we no longer have monomial denominators, we have polynomial. But nonetheless, when you add or subtract fractions, you have to have common denominators. So looking at these two denominators here, this one has x plus 5, this one has x times x plus 5. So for these to match, this one also needs an x. This one already has the x plus 5, it just needs the x to go with it. So I'm going to multiply both top and bottom by x, and I'm going to keep the bottom factored. Trust me, it makes your life easier. So here that would give me 2x over x plus 5. So like I said, little note you want to keep to yourself. Keep bottom or denominator factored. Okay, that's what you definitely want to do. So then here you've got plus 7x plus 10 over x plus 5. Now that my denominators match, you can go ahead and combine like terms across the top. Remember, when you add fractions, keep the bottom, add the tops. So I've got 2x plus 7x, which is going to give me 7, 8, 9. 9x plus 10, okay, over x plus 5. So the reason I said to keep the bottom or denominator factored is because now you can kind of see, well, if I need to factor the numerator, and anything comes out, will it cancel with the denominator? And no, anyway, because this one doesn't factor any further, but sometimes it will. So I'm finished, except I need to state my restrictions. X cannot equal 0, and x cannot equal negative 5. So that is my final answer with restrictions included. Okay. So on this second example here, this denominator has x plus 3, this one has x plus 3x minus 3. So to make these denominators match, I need to multiply this one by x minus 3 on top and on bottom. So here, remember, keep that denominator or bottom factored, but you are going to multiply into the top. So here you make sure and distribute in. Okay, so you would have 2x squared minus 6x over, just to keep it in the same order, I'm going to write x plus 3, x minus 3. So x plus 3, x minus 3. Okay, minus, I didn't need to mess with this guy, 36, x plus 3, x minus 3. And this 36 is over this whole thing. So now that the denominators match, I can go ahead and subtract. But you notice that's an x squared, that's an x, and that's a number. So there's nothing that I can combine. So I'm just going to rewrite it. I'm going to write 2x squared minus 6x minus 36 all over that common denominator of x plus 3, x minus 3. Then I'm going to try to factor the numerator to see if anything cancels. So I know that there's a GCF of 2, so that would leave me with x squared minus 3x minus 18 over x plus 3, x minus 3. And then to see if this trinomial here even factors any further, you would be looking for numbers that multiply to negative 18 but add to negative 3. So I'm thinking of numbers that multiply to 18, and that's going to be obviously 18 and 1, 9 and 2, 6 and 3. So would 6 and 3 work? Well, let's think about it. If I have x minus 6, x plus 3, is that going to work? Negative 6 times positive 3 is negative 18. Negative 6 plus 3 is negative 3. So that one's actually going to work. Over x plus 3, x minus 3. So here, when these two factors cancel, I'm left with 2, x minus 6 on top, and x minus 3 on bottom, where x cannot equal from the original here, numerator or denominator, excuse me, x can't be plus or minus 3. It can't be either or because of the denominator. So there you go on that one. All right, moving right along to number 3. So here you get a situation sometimes where your denominators have absolutely nothing in common. So in that unfortunate case, you just multiply them by each other. So I will multiply this by x plus 2 and x plus 2 on top, and I will multiply this by x minus 3 on top and on bottom. So remember that rule, keep the bottom factor, okay? So on top here, you're going to distribute in, and you're going to get 3x plus 6 over x plus 2, x minus 3, okay, minus, okay, when I distribute here, I get 5x minus 15 over x plus 2, x minus 3. Now that I have common denominators, I can go ahead and subtract. Oh, key thing here, make sure you distribute. So you would have 3x minus 5x, which is going to give you negative 2x, and then 6 minus negative 15. So minus a negative is going to turn positive. So that's 6 plus 15, which is going to give you positive 21 over x plus 2, x minus 3. Okay, x plus 2, x minus 3. Nothing on top can be factored. You can take out that lead negative. It's still not going to help you any. Okay, it's not going to cancel with anything down here. So we'll just leave it like that and say x cannot equal negative 2 and x cannot equal positive 3. Okay, so we're done on that one. Now last one here. So I've got 3 terms here. This one has x plus 2, x minus 2. This one has x plus 2. This one has x minus 2. So the common denominator to get would be x plus 2, x minus 2. So on this one here, we're going to multiply both top and bottom by x minus 2. Okay, and then on this one here, we're going to multiply both top and bottom by x plus 2. Okay, so on this one here, we are going to need to distribute. Same here. We're keeping this one the same, so I'm just going to drag it down. I'm going to kind of rewrite. So 6 over x plus 2, x minus 2, and then plus 5x minus 10 over x plus 2, x minus 2, minus 6x plus 12 over x, I'm just going to switch these so they're all in the same order, plus 2, x minus 2. Okay, and then I can go ahead and start combining my like terms. But again, key here is that minus sign. Okay, so make sure you distribute that. All right, so on top we've got 5x and a minus 6x, so that's going to create a negative x. And then 6 plus negative 10 minus 12. So 6 minus 10 minus 12. So you've got negative 22 here, so 6 minus 22. And that's going to create minus 16. Okay, and then you're going to have over x plus 2. Darn, I thought this was going to work out. X minus 2. And then you're going to have a lead negative. Honestly, if you factor out that lead negative, it's just going to make that x plus 16, and that's not going to help you any, so I'm not even going to do it. I'm just going to give my restrictions, which are x cannot equal plus or minus 2. So unfortunately, nothing canceled on that one. I thought it was going to work, and it didn't. Oh well, that's the way the cookie crumbles.